Hi, welcome to Competitive Cracker. So I hope you have started studying for your June CSIR net examination. So it is a right time to start studying, and it's a right time to accelerate your studies. So do your hard work, then only you will be rewarded. So I urge you to study CSIR physics in its right strategy, through its right strategy. So we need a proper strategic approach to clear CSIR physics examination. It is not as easy as other examinations that we have faced in our daily life. So CSIR physics examination requires that much preparation, that much temperament, and that much hard work to get it cleared. So winning CSIR with JRF is not that easy, but it is achievable. So you can definitely clear CSIR physics examination with JRF in flying colors, and you can do your research, and you can go for assistant professorship or anything you like. Your life will completely change after you achieve your JRF. So I request and I urge all of you to study CSIR physics examination with its proper strategy and do maximum problems as you can. Then only you can clear CSIR physics examination. So we have part A and part B and part C problems waiting for you. So part C problems is not that easy as you think, but with proper practice, then you can easily solve part C problems also. So part C problems is, though it is difficult, it could be done or it could be solved. So see, I have solved it. So then everyone can solve. That is my strategy. So I think with proper practice and practicing as much problems as you can clear part C problems also. Part B problems are not that difficult as compared with part C, but part B problems will some problems may be tricky. So if you have practiced many problems, and if you have gone through the tricks and traps of those problems, then part B and part C problems will not trouble you. So let us do some problems so that you can have a glimpse of the examination or what is being asked in the examination. So see, first question comes like this: a quantum mechanical system is in the angular momentum state defined by ket L equals 4, Lz equals 4. So ket ML is given, isn't it? So the uncertainty in Lx is, so you are asked to calculate the uncertainty in Lx. So this is a problem that comes from quantum mechanics, that too from angular momentum algebra. So you know, angular momentum algebra is very, very important in quantum mechanics. So there are many variety of problems coming from angular momentum algebra, especially from spin angular momentum algebra. So there are variety problems, that too part C problems. In order to understand those problems, we have to be very well known with the uncertainty, from the uncertainty principle, then commutation relations, then basic angular momentum algebra operations, and then some advanced level also. So these much prerequisites are required to do these problems. So you should focus on angular momentum algebra in a proper way. I hope after Schrodinger equation, applications of Schrodinger equation, angular momentum algebra is very, very important. Then comes linear harmonic oscillator and so on. So you study angular momentum algebra very seriously. So now let us do this problem. See, you are given the ket 4, 4. It is given, right? So L equals 4, Lz equals 4. So 4, 4 is given. So let it be there. So I am keeping it as such. So you know the operator Lx in terms of L plus and L minus. So what is Lx? So Lx equals L plus L minus by 2. So L plus L minus by 2. So you know what is here. So then I hope we have studied Lx expectation. Lx expectation. So expectation value means it is a expectation value with respect to a single state. So the expectation value with respect to a single state of this Lx is always 0. Why? We have studied and I have given you the explanations in the class. So Lx is equal to 0, and similarly expectation Ly will also be equal to 0. Ly be also equal to 0. So we have to calculate what? We have to calculate the uncertainty in Lx. So uncertainty Lx is what? Under root expectation Lx square minus expectation Lx square, isn't it? Expectation Lx square expectation minus Lx expectation square under root, isn't it? So this is what we have to calculate. So Lx is 0, so Lx square, so Lx expectation square will be equal to 0. So we have done with the second term. Then now we have to calculate what Lx square is. So what is Lx square? So Lx square equals L plus square plus L minus square plus 2L plus L minus by 4, isn't it? So we have to substitute for 2L plus L minus. So what is that? So it is L plus square plus L minus square, then plus 2 into, you know, this L plus L minus, that too we have derived in our classes. Please refer to that. So L plus L minus, what is L plus L minus? It is L square minus Lz square. L square minus Lz square divided by 4. L plus square, L square minus Lz square divided by 4. So now now we have to calculate the expectation Lx square. So expectation Lx square. So L plus square expectation. See, L plus raises the state by 1. So L plus expectation will be 0 and L plus square expectation will definitely be 0. Similarly, L minus lowers the state by 1. So L minus expectation will be 0. L minus square expectation will be definitely 0. Plus 2 into L square minus Lz square. So L square expectation is what? L square expectation is L into L plus 1 into h cross square minus Lz expectation is mh cross. So Lz expectation L square m square h cross square, right? Divided by 4. Okay, so what will be this? So this will be equal to 2 into L into L plus 1. L value is 4. 4 into 4 plus 1 is 5 minus m is 6. M is 4. M square is 16 into h cross square by 4. So 2 and 4, this will be 2. 5 4 is 20 minus 16 is 4. 4 by 2 is 2. So answer is 2h cross square. So answer is 2h cross square. So you know what is delta Lx. So delta Lx is under root Lx square expectation minus Lx expectation square. So Lx is 2h cross square minus 0. So what is your answer? It is root 2 h cross. So answer is root 2 h cross. So expectation. So here what you have to do is you should have a better idea about expectation values. So expectation values with respect to single state Lx, Ly, L plus, L minus. So since all these are 0, so you should have you should know what L plus L minus is. So substitute for L plus L minus, and you should have an idea about what is the eigenvalue of L square, what is the eigenvalue of Lz. Then substitute that and just calculate it, and you will get the value. Clear? So I hope this problem is very clear to you. So having done this problem, now let us move into the next one. So yes, see, we have launched our JRF Victory batch. See, setting up with assistant professorship or admission for PhD only will not earn you a better life, or will not earn you a better fellowship. So clearing CSIR physics examination with JRF must be your dream. So you can have about 50,000 rupees per month for JRF, and it will increase up to 60,000 in SRF. So for 5 years you will have a better earning, that too without any tax. So you can conquer JRF with confidence with competitive cracker. And our JRF Victory Batch admissions are now on, and you can contact us in the given number. And I welcome you all to our JRF Victory Batch, and through our intensive coaching. So we have live classes, we have recorded classes. In the live classes we are discussing exclusively problems, that to previous year problems, model questions, and all those things are discussed in the live classes. That you will have 2-hour live classes each day, and you will have assignments that help you to do maximum problems. So each day you will be given assignments, and each day you will be assigned to watch those videos, recorded videos, and you will have examinations, weekly examinations twice on Wednesdays and on Saturdays. So you will have 2 examinations per week. So all these examinations will help you to get rid of the fear of doing problems. And also we will have model examinations, cumulative examinations. So you will be forced to revise. So by continuous revision, continuous focus on important topics, all those exercises will help you to conquer JRF definitely with confidence, and you will be your fear will be eradicated. So Competitive Cracker welcomes you all to our JRF Victory Batch, and I hope that we can meet you in the classes. So now let us move into the next problem. See, an integral is given by integral minus infinity to plus infinity dx, integral minus infinity to plus infinity dy, exponential minus of x square plus y square plus 2axy, where a is a real parameter. Then the full range of values of a for which the integral is finite is. See, here we have to solve the integral not in a direct way. So this comes from mathematical physics, from the topic of Jacobian transformation. So you have studied Jacobian transformation in classical mechanics, and the application of that Jacobian transformation is coming here. So we have to do this integral, and we have to calculate the full range of values of a for which the integral is finite. So that finite value should be calculated. So what are these ranges given? From minus infinity to infinity, minus 2 to 2, minus 1 to 1, and minus 1 less than equal to 1, less than equal to 1, minus 1. Okay, so these are the values given. Okay, so now let us do this problem. See, what is your integral? Integral is integral minus infinity to infinity dy, integral minus infinity to infinity exponential integral minus infinity to infinity dx, right? So dx, integral minus infinity to infinity dy into exponential minus of x square plus y square plus 2axy. So here since this has to be finite. See, what should be finite? See, this x square plus y square plus 2axy should be greater than 0, isn't it? 2axy should be greater than 0. So then now transform this. Now apply transformation. So the transformation x is equal to u plus v, and y equals u minus v. Okay, we have studied this. So x is equal to u plus v and y equal to u minus v. Substitute it here. So what will you get? So here x square plus y square plus 2axy. So you should not substitute the integral and perform the integration. You just substitute this in the function. So what will you get? The function will be u plus v whole square plus u minus v whole square plus 2a into u plus v into u minus v. U plus v into u minus v. So this should be greater than 0. So this should be greater than 0. Then you should get care of that inequality. Okay. So what is this then? U plus v whole square plus u minus v whole square. U plus v whole square plus u minus v whole square. So what is this? U square plus 2uv plus v square plus u square minus v square. U square plus v square minus 2uv plus 2a into u plus v into u minus v, u square minus v square greater than 0, right? So 2uv and minus 2uv cancels. So what will you get here? So this will be u square plus u square 2u square, v square plus v square 2v square. So 2 into u square plus v square, 2 into u square plus v square plus 2a into u square minus v square should be greater than 0. Should not forget about the inequality. So here now group the terms of u square and group the terms of v square. So here there is 2u square and here you have 2a into u square. So 2 plus 2a into u square plus here you have 2v square, here you have minus 2a v square. So 2 minus 2a into v square should be greater than 0. So it should be greater than 0. So this plus this should be greater than 0. That means 2 plus 2a should be 2 plus 2a should be greater than 0 and 2 minus 2a should be greater than 0. 2 minus 2a should be greater than 0. So what will happen? So 2 plus 2a greater than 0. That means so from this 2 should be greater than minus 2a and a here will be minus 1 and here a will be 1, isn't it? A here will be minus 1 and a here will be 1. Then your range will be what? Minus 1 less than a less than 1. So this is the range. This is the full range of a in which the integral will be finite. So this is just by logic you can have the value of a. So I hope this is very clear, and this is an example of that tricky problem. Here you should not perform the integration. If you perform the integration, you will not get the answer. Okay, so here you have to play with the integrand, not with the integration. So if you do the integration, you will be deviating from the path, and if you and for this we require much practice. So you should understand which problem requires doing that and which problem requires an analysis. So this problem requires only an analysis, not this is not checking your ability to do or perform an integration. So this problem checks your analytic skill. Okay, so you should analyze this problem and get a conclusion. That is what it is required. That is what is required here. Clear? So I hope this problem is also very clear, and do not forget about our JRF victory batch, and I hope you have understood the process by which we are preparing you for the JRF. So our JRF victory batch is ongoing, and I welcome you all to our JRF victory batch, and let us study together, and we will see you with another video. Thank you.